It is a beautiful summer's day on the Mahia Peninsula on New Zealand's east coast, where Electron is vertical on the launch pad and ready to head to space for the second time in 48 hours, this time for the Korea Advanced Institute of Science and Technology, known as KAIST. Welcome to Launch Complex 1 for Rocket Lab's 20th Electron launch of the year. Thank you for joining us. My name's Kim Thompson. I'm a structural analyst in the Neutron team, and with me is Muriel Baker, our Director of Corporate and Launch Communications.
Thanks, Kim. We are launching Electron today from Pad A at Launch Complex 1, one of our 2 launch pads within our private launch site. And launch preparations have run smoothly this morning in the lead up to our 1:55 p.m. local time liftoff target for today's mission. That is 7:55 and 4:55 Eastern and Pacific, and 9:55 a.m. in Korea Standard Time for our payload operators. Now, today's mission is called Bridging the Swarm, in a nod to the beginning of the Swarm mission that we launched for KAIST last year. That was the first launch for their NeonSat constellation of Earth imaging satellites.
Today, Electron will head to a 540-kilometre low Earth orbit at a 97.4-degree inclination to deploy NeonSat 1A. This will link communications between that first satellite and the rest that are scheduled to join the constellation over the next 2 years. KAIST and KASA, which is the Korean Aerospace Agency, will use satellite data from the constellation to monitor for natural disasters and respond to national security events across the Korean peninsula. Here's more from KAIST. We are thrilled to be launching another mission for KAIST in collaboration with SATREC, the Korean Aerospace Research Institute, and the Korean government's Ministry of Science and ICT. Now, taking a look at the countdown to launch, we are now T-minus 12 minutes and 28 seconds to lift off. At T-minus 12 minutes exactly will be our go, no-go poll for today's mission, run from Mission Control by our launch director, Yulia Wimbaka. Each of our launch operators will check in from their stations to confirm their systems are operating as they should, and also to confirm that the range in Mahia is ready to support. So let's listen in.
And to all operators, LD on mission code, we are proceeding with the go-no-go sequence, starting off with stage.
Stages go.
Avionics.
Avionics is go.
GNC.
GNC is go.
Recon.
Recon is go.
T1.
T1 is go.
GC.
GC is go.
PLS.
PLS is go.
RSO.
RSO is go.
MET.
MET is go.
MM.
MM is go.
The go-no-go sequence is complete. We are T-minus 11 minutes and 25 seconds in counting. We are go for terminal count auto sequence at T-minus 10 minutes. From this time, the three-way procedure is in effect.
Nice one out of Mission Control there, with a clean run across our launch operators that moves us forward for today's launch at 1:55 p.m. local time in just over 11 minutes. Now, an earlier weather report had today's conditions at 95% favourable for launch today, and all other launch vehicle and payload checks are proceeding nominally. So while we're taking a look at Electron on the pad, here is more about what makes up our small lift rocket. So Electron is a carbon composite launch vehicle that can lift up to 320 kilograms to low Earth orbit, and it has 3 stages: a first stage, a second stage, and a kick stage inside Electron's fairing that will carry NeonSat to its orbital destination. Overall, the rocket is 18 meters in length, or about 59 feet, and its diameter is just over 1 meter.
We run 2 propulsion systems across Electron. The first involves the Rutherford, our 3D printed electric pump-fed rocket engine. Now, there are 9 of these at the bottom of that first stage, and a single space-optimized Rutherford engine on the second stage. For the kick stage, we use the Curie propulsion system, a much smaller engine that we use for orbital maneuvering and positioning. This engine is capable of multiple restarts and tightly timed engine burns to deploy the mission's payload to orbit. Now, precise positioning is especially important for Earth imaging missions like KAISA's, and the kick stage is capable of deploying satellites to within just meters of its target. That is an incredible feat, considering that the kick stage travels at an orbital velocity of around 8 kilometers per second.
Now, that incredible accuracy allows small satellite operators to choose the exact parameters that are critical for their missions, like altitude and inclination, where the orbit directly impacts the satellite's performance for Earth observation, communications, and a whole lot more. And Electron has deployed more than 200 satellites this way across 77 launches as of this weekend. And with today's launch, we are about to add another to the tally for Electron's 78th launch in just 9 minutes' time. Now, while we've got a moment, I want to bring your attention as well to one of the newer benefits of our workhorse Electron rocket. Now, these missions give us the unique opportunity to test components and technologies in space for our new, much larger rocket, Neutron. And today, we are testing some thermal protection system panels, or TPS panels, which you'll be able to spot through our external camera. Our Neutron team will then use these views to confirm that the material properties of the panels match our models and simulations. And now, during ascent, you might notice that these panels degrade and peel off during the stage 1 burn, but do not worry, that is completely intentional. And we'll be sure to remind you of it when it happens, so make sure you stay tuned.
Now, today's launch will also be our 20th of the year, and all but 3 of them have taken place from right here at Launch Complex 1. We operate 2 launch pads from our private launch site on the Mahia Peninsula, Pad A, which we're flying from today, and Pad B, just a few metres away, which hosted our most recent Electron launch on the weekend. And in fact, over at our Mid-Atlantic Regional Spaceport in Virginia, Launch Complex 2, we have a 3rd Electron pad there as well, where we are just wrapping up the launch rehearsal for our next launch that will fly from there later this week.
Now, having these dedicated pads, especially having 2 of those in play within the same site, means that we can launch from one and then move straight onto the next pad while the first one is being made ready for the launch after that. And that's exactly what we need to run back-to-back missions like we're doing today. Here's more about Launch Complex 1.
The Launch Complex 1 is Rocket Lab's privately owned launch complex here in New Zealand, in one of the most remote parts of the country, in a remote part of the world. We have 2 launch pads, as well as a large hangar where we can process multiple Electron vehicles simultaneously, and a number of clean rooms where customers can work on their payloads and integrate their payloads into Electron. The location that we're in here in New Zealand is fantastic. There are very few airplanes flying above us, there are very few ships in the seas around us, and so it's both easy for us to manage those during a launch campaign, and also does not prohibit us from launching pretty much any time. The fact that Rocket Lab owns and operates LC-1 on their own, it's extremely advantageous. It means that we have full control over everything that goes on there. We have first and only priority, and we can do with it what we want. So we can configure things exactly to how Electron is designed, and we can make it work specifically for our needs so that we can turn around launches as fast as anything. We also operate from LC2, which is Wallops Flight Facility. It's a very similar activity over there. We just have some other parties that are involved. We have some really great partners that help us with those operations. We've proven that we can launch one rocket after another within 24 hours. And with all the pads occupied, we could do the same for 3 rockets in 24 hours as well. So as the launch rate picks up around the world from all providers, it prohibits flexibility in a lot of cases. So if you are operating from a pad at federal launch sites and another organization is also operating and they have an issue on their vehicle and they have to delay a day, that may affect your opportunities to launch or other parties' opportunities to launch. And it's this cumulative effect that means that everyone's sort of impacted by everyone else. Whereas with our own launch site that we have full control over and are the sole operators at, if we have to delay a day for weather or similar things, then not a big deal. We don't need to stop anyone else from launching, we deal with it ourselves. When we did our first Electron launch from LC-1, it was not only an accomplishment for Electron as a vehicle, but also the fact that we were the first in the world to have a private orbital launch site. And that was a huge deal. You know, the regulatory hurdles that we had to jump through and the efforts that it took to make that happen were just as big of a deal as to get Electron off the pad. And so that was a huge accomplishment, an exciting accomplishment, and we've just leveraged that since then. And, you know, as I've said, added another pad and made it just more and more easy for us to do it. And it's just so liberating to have the freedom to operate from there. So it's the most beautiful launch pad in the world, without a doubt.
I might be biased, but I agree with Michael there. Absolutely gorgeous.
Okay, time now to turn back to the countdown to launch for Electron. And we are at T-minus 3 minutes, 43 seconds and counting until we send NeonSat 1A to space for KAIST. And we are tracking no issues with the rocket, the weather, or the range in these final few moments. Very soon, Electron's autonomous flight computer will take over and run the last 2 minutes or so of operations on its own, which includes finalizing the propellant load and checking that both stages of the vehicle are fully pressurized for launch before liftoff.
At T-minus 10 seconds, our launch director will count down from mission control before Electron launches off the pad at LC-1 for this mission. It's about that time, so let's listen back into MCC to hear those final moments before launch. Go Electron and go KAIST.
Code. From now on, there should be no red flags on your critical LCCs. VCON LD on mission code.
LD VCON.
Block the auto sequence and confirm.
Confirmed.
Confirm all flight computer ASCOs are green.
Confirmed.
To all operators, we are go for auto sequence start at T-minus 2 minutes. LDs go for launch.
The vehicle is fully on internal power. AFTS is green, enable for flight. Locks load complete, system is in recirculation. Anti-geysering is disabled.
Stage 1 and Stage 2 tanks are pressed for flight.
High flow engine purge enabled.
T-minus 20 seconds and counting. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. Abort. To all operators, we are proceeding with the immediate abort sequence. GC LD mission code.
LDGC.
Confirm the range state is inhibit.
Confirmed.
And GC, please confirm the stage 1 and stage 2 umbilical status is engaged.
Confirm.
Okay, just confirming what we heard from Mission Control there. Sounds like an abort was called in that countdown, so we are waiting to hear more from Mission Control.
The stage terminal board checks sequence 70.
Copy and work.
At this point, we are not recycling, we are scrubbing for today. PLS LD mission code.
LD PLS.
Proceed with the PLS prep and detank sequence 72.
Copy sequence 72 and work.
Okay, we heard it from Mission Control there with the short launch window for today and that abort called right at liftoff. It looks like we won't be recycling the count today and we'll be standing down. Thank you though for sticking with us, and we'll provide updates on our website and social media channels as soon as we have them.